everyone. Today's lesson, or last time, we uh, we went over or learned about types of bonds, um, covalent, ionic. Um, we learned about ionic, complete transfer, and then covalent is sharing. And then we learned there's equal sharing and there's non-equal sharing. So polar and non-polar. We also learned the crisscross method, which is balancing of charges until you form neutral compounds. So we've learned the type of bond, how it's formed, and how you name it. Okay. Now in this lesson, we're going to learn how do you put it all together and balance it. So you go from word to formulas to balancing. And we're learning evidence about chemical reaction. So here's the objective for today. Recognize the evidence of a chemical reaction or chemical change. Represent chemical reaction with equations, and then balance the equation. Um, Review vocab, it's just chemical change. It's a process involving one or more substances changing into a new substance. And these are the new terms: reactant, product, and coefficient. In your focus, you're giving you this picture right here, and then they asking you to describe the changes. Some of the changes might compare it to fresh tomato. What do you see that's different compared to color, texture, smell? And then, is this reaction reversible? Now, later on, we're going to learn about equilibrium in chapter 18, but in this case, none of these reactions are reversible. And the identity changes, but in this case, instead of fresh tomato, it's a rotten tomato. Chemical reaction.
Chemical equation. A statement using chemical formulas to describe the identities and relative amounts of the reactants and products involved in the chemical reaction.
Okay. He actually went over different terms. But chemical reaction is rearrangement of substances from the reactant to the product. And in order to know if the reaction is happening, there are evidence that you can see. Maybe change of temperature, change in color, bubbles maybe, odor given off, gases. Now, a change in temperature, we've learned this about last semester in thermodynamics, where exothermic and endothermic heat is given. Maybe you feel the flask getting hot, and that's exothermic, or that is getting cooler, and that's endothermic. Heat is being absorbed from the surrounding. And in a chemical reaction, there are two parts. There's a reactant and product.
Reactant. The starting substance in a chemical reaction. Product. A substance formed during a chemical reaction.
Okay, so what we start with is called reactant, and when we end up with is the products. Symbols that we should be aware of are pluses. They separate the reactant, two or more reactant or products, and the arrow just separates the reactant from the product. We're not going to use this one yet. We'll use it later on when we learn equilibrium. And then the states are solid, liquid, gas, and aqueous. Aqueous just means mixed with water. Now, a couple of things that we need to remember when we're going from word equation to formulas are some elements are binaries. That means they're highly reactive and they never exist by themselves, like hydrogen, oxygen, nitrogen, and all of the halogens. They never exist by themselves. So maybe write this down when you're writing formulas from words to formulas. Just you need to remember, and we'll practice today that too as well.
Chemical equation. A statement using chemical formulas to describe the identities and relative amounts of the reactants and products involved in the chemical reaction.
Okay. We go from word, which is we see something like this, and reads aluminum and bromine reacts to produce aluminum bromide. So this is a word equation. And then we go to formulas. We break them down. Aluminum is Al, bromine is Br, but we have to remember they're binary, so it's Br2. And then aluminum bromide, aluminum is in 3A, which is you lose 3, becomes positive 3. Bromine has 7. You gain 1, so you do the crisscross, and the formulas we get. So this is the equation that we have. The only thing, now notice here there's 3 bromine and this one is 2, so we need to balance it. So in order to balance it, the only thing we can change is called the coefficient.
Coefficient. In a chemical equation, the number written in front of a reactant or product. In a balanced equation, describes the lowest whole number ratio of the amounts of all reactants and products.
Okay, so we cannot really change the subscript or that little number right here. We only can change the coefficient, their number in front. So we don't add, we don't subtract, we don't divide, we can only multiply by the coefficient. And it has to be the simplest whole number ratio. All right. Now we do the balancing in order to satisfy the law of conservation of mass. Nothing gained, nothing lost. So that's the purpose of really balancing. Okay, let's practice. Write skeleton equation, but we're not going to just do the skeleton. We're going to do the whole thing. We're going to balance. But when they say the skeleton, you don't have to balance. But for our class, we balance. So hydrogen, it's a binary. Bromine is binary. So and hydrogen bromide +1, -1, crisscrosses on each. So the first step, you want to divide this in half, right on the arrow. So everything on this side has to equal everything on this side. This side right here is the reactant, and this whole side here is the product. So you have 2 hydrogen, 2 Br, 2 bromine, and then on this side 1 and 1. Of course, to balance, you just change the coefficient to 2, and that changes the hydrogen and the bromine because it's multiplied the hydrogen and the bromine. And then you're done. You're balanced. Of course, you can pause. I'm going through quickly because I only have 15 minutes. Carbon monoxide plus oxygen yields or produces carbon dioxide. So we divide and we count the elements. We have 1 carbon. Now you have 1 oxygen and 2, that gives us 3 oxygen right here. 1 carbon on this side and 2. So let's see, how do we balance the oxygens? If we multiply this one by 2, that gives us 2 carbons and 4 oxygens. Now when you multiply the carbons by 2, that gives us 2 carbons, but then 2 plus 2 is 4, so now it's balanced. Now this one has polyatomic, so you might want to have your polyatomic handy when you're doing your Teach Me assignments or your homework. There's handouts, 2 handouts I think. Potassium chlorate, ClO3 negative. Potassium produces or yields potassium chloride plus oxygen. 1K, 1Cl, 1O, 1K, 1Cl, 2 O's. So in order to balance the oxygens, You multiply this one by 3 to get 6. Multiply this one by 2 to get 6. But then you're also multiplying the potassium and chlorine, so 2 and 2. So now you multiply KCl by 2 and they get 2 and 2. Now it's balanced. Now this one, a little bit complicated, but if you break it down, it's not so bad. Also polyatomic right here. Hydroxide is OH. Iron 3, remember this is a transition. So it just means we have 3 chlorines. Reacts with sodium, NaOH. Produces, that's an arrow, solid iron 3 hydroxide. So, right here, iron 3 hydroxide plus sodium chloride and NaCl. Now, just a hint, if you have OH on this side and OH, don't separate. So it's a polyatomic on both sides, except the number on the outside of the parentheses. Don't separate them. So let me show you how to do this. Iron, chlorine, and sodium, and OH. Iron, chlorine, sodium, and OH. So you have 3 chlorines and 3 OH. Let's balance the OHs first. You have 3 OHs. So you multiply NaOH on this side. That gives 3 NAs and 3 OHs. So now we have to balance the Na on this side. So you multiply that by 3. But then you're also multiplying the Cl by 3. 3 Cl, 3 Na, 3 OHs. So when you break it down, it's not so bad. I think we have a couple more. Carbon disulfide reacts with oxygen to produce carbon dioxide plus sulfur dioxide. So let's see, let's break it down. We have carbon, sulfur, oxygen, carbon, sulfur, and oxygen. Let's see. 2 sulfur, 4 oxygens. So to balance the sulfur, you multiply this one by 2 to give 2 sulfur. But then you're getting 4 plus 2 oxygen is 6. So everything okay except the oxygen. So we multiply this one by 3. That gives 6. And that's balanced. I think that's the last one. Zinc plus hydrogen, H2SO4. And it's 2 because SO4 is negative 2. Yields or produces hydrogen, binaries. And then zinc sulfate. Zinc is positive 2, sulfate is negative 2. Now you have zinc, hydrogen, sulfur, sulfate. We keep it together because sulfate on both sides. Zinc, hydrogen, sulfate. They're already balanced. 1 zinc, 2 hydrogen, 1 sulfate. Okay, I hope that helps with the handouts. If you need, I can upload another video to help you with the Teach Me. Just let me know. Okay, thank you everyone.